morning everyone, I'm Montesa Agsoy and our topic is all about the beginning in Western Europe. But before that, here's the objectives. By the end of the lesson, you shall be able to know about mathematics in Western Roman Empire, discover the flow of math knowledge to the different parts of Europe, and identify the famous mathematicians in Europe on this period and their inventions.
So before anything else that I will discuss for today, I would like to introduce myself first. I'm Jennifer Zanuan, the group of rappers. We are the group 1, and for today, I will discuss the beginning in Western Europe. What is a beginning in Western Europe? So the beginning of Western Europe is a European region farthest from Asia. The region countries and territories vary depending on context. Beginning with foreign exploration during the Age of Discovery, roughly from the 15th century, the concept of Europe as the West gradually became distinguished from and eventually replaced the dominant use of Christendom as a preferred antonym within the region. Later, during the Age of Enlightenment, the concept of Eastern Europe was created to juxtapose that of Western Europe. So let's proceed to when did Europe begin? The beginning of the early modern period is not clear-cut, but it is generally accepted to be in the late 15th century of the early century. Significant dates in the transitional phase from medieval to early modern Europe can be noted in 450. So the next is what period started in Western Europe. It all started in the period of Middle Ages or Migration period, also called Dark Ages or Early Middle Ages. The early medieval period of Western European history, specifically the time in 476 to 800 CE, when there was no Roman or Holy Roman Empire in the West, or more generally, the period between about 500 and 1000, which was marked by frequent warfare and virtual disappearance of urban. The name of the period refers to the movement of so-called barbarian peoples. So let's proceed to the continuous. It is including the Huns, Goths, Vandals, Bulgars, Alani, Suebi, and Franks into what had been the Western Roman Empire. The term the Dark Ages is now really used by historians because of the value judgment it implies in Western Europe. Western Europe is a European region farthest from Asia. The region's countries and territories vary depending on context. So the Western Europe, that country that included is France, Spain, United Kingdom, Germany, and etc.
Good day everyone, I'm Diana Celo, and to be continued, I will discuss the mathematics in Western Roman Empire. Mathematical studies and discoveries during the early Dark Ages in Europe were extremely limited. One illustration of this fact is that chronology of the highly esteemed English scholar Bede. The Venerable Bede, 672 over 673 to 735, which set the convention that the year 1 BCE immediately precedes the year 1 AD. This remains unchanged even though 0 is now generally accepted to be part of the number system. During the second half of the 11th century, some important political developments helped raise European consciousness of ancient Greek mathematical work and the more recent advances by Indian and Arabic mathematicians.
These are the specific examples of particular importance for mathematics during the time of the Norman conquest of Sicily in 1072, the Spanish Reconquista, during which extensive and important territories in the Iberian Peninsula changed from Muslim to Christian hands, and the start of the Crusades in 1095. In 12th century, from a mathematical perspective, one important consequence was dramatically increased access to the work of Arabic mathematicians and their translations of ancient Greek manuscripts. Effort to translate these manuscripts into Latin continued throughout the 12th century. The quality of these translations was uneven for several reasons, but this was an important step to promoting mathematical activity in Europe. However, there were contributors to the subject during the period from the Latin commentator. His name is Boethius. Shortly after the fall of the Western Roman Empire and continuing through the end of the 12th century, Boethius has been described as the last of the Romans and the first of the scholastic philosophers, predating the latter by many centuries, and his mathematical texts were still widely used 600 years after they were written. So, moving on to Fibonacci, I know that all of us familiar and know him. He is more frequently known by the 18th century nickname Fibonacci, symbolized the revival of mathematical activity in Europe during the late Middle Ages, and his book is Liber Abaci. So let's know about Liber Abaci. So Liber Abaci is a book of accounting, literally the abacus, which appeared in 1202. Is the first major work aimed specifically at a European audience that recounts some important ideas from Hindu and Arabic mathematics and integrate this work with that of earlier contributions from Greek mathematics. The work is not merely a routine compilation of material from other sources, but rather it represents an independent and broadly based point of view. Despite the impact of Liber Abaci during the late Middle Ages, the first printed version did not appear until 1857, nearly 650 years after it was first written. Incidentally, the first published English translations of this work appeared in 2003. And these are the comments on the contents of Fibonacci's writings. Moving on to the class formula for Fibonacci numbers. In 1843, Binet gave a formula which is called Binet's formula for the usual Fibonacci numbers. So we can use this formula to the Fibonacci equation. This is another noteworthy achievement of Fibonacci was his solution of cubic equation, which was reported. So let's move on to Jordanus Numerarius, who made contributions in several areas. He successfully analyzed mechanical problems about inclined planes that Archimedes had not been able to solve. He discovered some basic relationships between the plane and the spherical geometry. He was the first Western mathematician to use letters consistently as symbols for unknown quantities. Jordanus proved a basic relationship between perfect and non-perfect numbers. Moving on to Nicola Resmi, who is widely viewed as an important figure in 14th century mathematics. Oresme made several highly original contributions to mathematics, many of which were centuries ahead of their time and some of which had a more immediate impact. So first, we have the fractional exponents. Oresme proposed a mathematically sound way of defining the positive fractional powers of a number and even raised the possibility of irrational powers like square root. Second is graphical representation of functions. The book Tractatus de Figuration Potentiarum et Mensurarum, Latitude of Forms, written by Oresme or one of his students, popularized the idea of representing variable quantities graphically. We have already noted that the methods of Apollonius had anticipated the development of coordinate geometry much earlier, but the idea of representing variables was presented very clearly in Oresme's work, and its influence can be measured by the numerous editions of his work that were published well into the 16th century. His suggestion that certain physically measurable quantities are continuous has been implicitly assumed in many applications of mathematics to science and engineering for centuries. Oresme also speculated about graphical representations of quantities dependent on two variables by surface in 3 dimensions and possibly about analogs in even higher dimensions, but the mathematical notations at the time was inadequate. And last is infinite series. During the 14th century, Western mathematicians began to cast aside the Greek reluctance to consider infinite processes, and in particular various infinite series were studied. It should be noted that the Indian and Chinese mathematicians had studied such series much earlier, and some particularly noteworthy results of their from earlier times through the 15th century were rediscovered after the relevance of calculus to infinite series became apparent in the early 18th century.
And now let's proceed to the flow of mathematics knowledge to the different parts of Europe. Europe had accepted calculus and algebra from India and East countries until 900s, although the Arabic mathematicians are most famed for their work in algebra, number theory, and number systems. They also made considerable contribution to the geometry, trigonometry, and mathematical astronomy. And now, let's proceed to the different parts in Europe, in Greek, Roman, and Italy. Greek made a hugely significant contribution to world thought and all practical subjects which depend on that intellectual basis, from geometry to engineering, astronomy to design. It is also influenced initially by the Egyptians. Greek mathematicians would push on to make breakthroughs such as Pythagoras' theory and right-angle triangles, and by focusing in the abstract, bring clarity and precision to age-old mathematical problem. And in Greek, their solutions provided the fundamental mathematical building blocks that all future mathematicians and scientists would build upon right up to the present day. And in Romans used mathematics just for practical purposes like trade, division of land, creating buildings, etc. And also due to cumbersome nature of Roman numerals, they could not go much beyond the simple arithmetics, which was also not easy to learn. Despite advances in many areas, Romans were happy with mathematical rules of thumb, a Roman abacus. Roman abacus used by sliding counters along rods and grooves used to perform mathematical function. It is also called as counting frame, which commonly used ancient times. They regularly applied simple mathematics to solve practical problems, and Roman numerals, they could not go much beyond the simple arithmetics, which was also not easy to learn. And Roman numerals are used even today, especially where large numbers are not required, like on clocks, writing pages, numbers, and book before the index card. In Italy, there are a lot of greatest mathematicians who give influences in this part of Europe, and one of those are Archimedes and Fibonacci. Archimedes anticipated modern calculus and analysis by applying the concept of the infinitely small and the method of exhaustion to derive and rigorously prove a range of geometrical theorems. And Archimedes' discovery also the relationship between the surface and volume of a sphere and its circumscribing cylinder. Example, the area of a circle, the surface area and volume of a sphere, area of an ellipse, the area under parabola, and the volume of a segment of a paraboloid of revolution. Leonardo Fibonacci, he also introduced Europe to the sequence of Fibonacci numbers, which he used as an example in Liber Abaci. This is a book to describe the Hindu-Arabic numeral system and to use symbols resembling modern Arabic numerals. Fibonacci was celebrated also in medieval Italian mathematicians. He is deemed the most brilliant Western mathematician during the medieval time, and he composed a book employing that numeral system, Liber Abaci, or the Book of Calculations. There are two countries contributed to the development of the European Middle Ages mathematics, the Arabian mathematics and Indian mathematics. Greek mathematicians were good at geometry, but they were not at arithmetic and algebra because they didn't use signs. But Indian mathematicians actively used symbols, and they made Indo-Arabian numbers. They also used decimal system. Indian mathematicians thought that negative numbers for the first time, and they made it rule. And aside from that, Arabian ruled parts of North Africa and Europe for 400 years. Then, they had new mathematics which way mixed Greek and Indian mathematics.
And as we continue, you will discover many different mathematicians in Europe on this period and their inventions or contribution to mathematics. One of them is Gottfried Leibniz. He is an incredible mathematician with the most fabulous head of hair. Leibniz was a German polymath, active as a mathematician, philosopher, scientist, and diplomat. Yes, he is a prominent figure in both the history of philosophy and the history of mathematics. Furthermore, he wrote works on philosophy, theology, ethics, politics, law, history, and philology. He also contributed to the field of library science while serving as overseer of the Wolfenbüttel Library in Germany. To add, he devised a cataloging system that would have served as a guide for many of Europe's largest libraries. He is known as the inventor of mechanical calculators and added multiplication and division functions to Pascal's calculator. Leibniz's contribution to this vast array of subjects were scattered in various learned journals, in tens of thousands of letters, and in unpublished manuscripts. He wrote in several languages, primarily in Latin, French, and German, but also in English, Italian, and Dutch. The next mathematician is William Playfair. He is a Scottish engineer and political economist. Served as a secret agent on behalf of Great Britain during its war with France. Playfair invented several types of diagrams in 1786. The line, area, and bar chart of economic data. And in 1801, he invented the pie chart or circle graph that is used to show part-whole relation. That is why he is known as the founder of graphical methods of statistics. Now we have James Maxwell. James Maxwell was also a Scottish mathematician and also a scientist responsible for the classical theory of electromagnetic radiation, describing electricity, magnetism, and light as different manifestations of the same phenomenon for the first time. Maxwell's equation for electromagnetism have been called the second great unification in physics, where the first one had been realized by Isaac Newton. In addition, he developed a color photograph, which makes him the first color photographer. The fourth mathematician we have is Alan Turing. He is considered to be the father of theoretical computer science and artificial intelligence. He was an English mathematician, computer scientist, logician, cryptanalyst, philosopher, and theoretical biologist. Alan was highly influential in the development of theoretical computer science, providing a formalization of concepts of algorithm and computation with the Turing machine, which can be considered a model of a general purpose. Next, we have Pierre-Simon Laplace, known as the pioneer of statistics. He was a French scholar and polymath whose work was important to the development of engineering, mathematics, statistics, physics, astronomy, and philosophy. He summarized and extended the work of his predecessors in his 5-volume Mécanique Céleste, or Celestial Mechanics, on 1799 to 1825. This work translated the geometric study of classical mechanics to one based on calculus, opening up a broader range of problems. In statistics, the Bayesian interpretation of probability was developed mainly by Laplace. As we go through, we have Thomas Bayes, known as the advancers of statistics. He was an English statistician, philosopher, and Presbyterian minister who is known for formulating a specific case of the theorem that bears his name, Bayes' theorem. Bayes never published what would become his most famous accomplishment. His notes were edited and published after his death by Richard Price. Next is Charles Babbage, a mathematician, philosopher, inventor, and mechanical engineer, known as a computer visionary. He first invented a mechanical computing device. Moving forward, we have Ada Lovelace, or Augusta Ada King, Countess of Lovelace. She was known as the first computer programmer. Also, she is an English mathematician and writer, chiefly known for her work on Charles Babbage proposed mechanical general-purpose computer called the analytical engine. She was the first to recognize the machine had application beyond pure calculation and to have published the first algorithm intended to be carried out by such machine. As a result, she is often regarded as the first computer programmer. The ninth famous mathematician in Europe is David Hilbert, known as the patron saint of math teachers. He was a German mathematician and one of the most influential mathematicians of the 19th and early 20th centuries. Hilbert discovered and developed a broad range of fundamental ideas in many areas, including invariant theory, the calculus of variation, commutative algebra, algebraic number theory, foundations of geometry, spectral theory of operators and its application to integral equations, mathematical physics, and the foundations of mathematics, particularly the proof theory. Next, we have Euclid, sometimes called Euclid of Alexandria to distinguish him from Euclid of Megara. He is known as the prover of math, as he is the first to formalize mathematical proofs. In addition, he was often referred to as the founder of geometry or the father of geometry. His Elements is one of the most influential works in the history of mathematics, serving as the main textbook for teaching mathematics, especially geometry, from the time of its publication until late 19th or early 20th century. In the Elements, Euclid deduced the theorems of what is now called Euclidean geometry from a small set of axioms. Euclid also wrote works on perspective, conic sections, spherical geometry, number theory, and mathematical rigor. Lastly, we have Isaac Newton. We all know that Isaac Newton is the inventor of calculus. Also, he was an English mathematician, physicist, astronomer, theologian, and author, widely recognized as one of the greatest mathematicians, physicists, and most influential scientists of all time. Newton developed early physics, a scientific method, the theory of universal gravitation, and of course, the calculus.